Welcome to day 15 of our bits series. Today we will explore the bitwise AND operation denoted by the ampersand symbol. Let's dive into how this operation works and its applications. The bitwise AND operation is represented by the symbol ampersand. This operation works by comparing each bit of two numbers. The result bit will be 1 if both corresponding bits are 1 and 0 otherwise. Essentially, it's a bit by bit comparison. Let's look at the truth table for the bitwise AND operation. It shows that the result of applying AND to a pair of bits. Notice that for a bitwise AND to return 1, both digits must be 1, otherwise the result is 0. Here's a practical example. We have two numbers 12 and 10. In binary, 12 is 1100 and 10 is 1010. Applying the bitwise AND, we get the result 1000, which is 8 in decimal. So 12 and 10 equals 8. Bitwise AND has several real-life applications. For example, we can use it to check if a number is even or odd. If a number and 1 equals 0, it's even. It's also useful for masking bits, which helps isolate or modify specific bits in a number. Additionally, bitwise AND is used in permissions systems where you check if certain flags are enabled. Let's take a look at some C++ code. In this example, we have two variables, a which is assigned 12 and b assigned 10. We applied the bitwise AND operation a and b, which results 8. The code prints 8 as the output, which is the bitwise AND of 12 and 10. Be careful not to confuse the bitwise AND with the logical AND. The bitwise AND compares bits individually, whereas the logical AND evaluates the truthiness of entire expressions. So remember, ampersand is for bits and ampersand is for logic. Here's a fun fact. The bitwise AND operation is one of the fastest operations a CPU can perform. This is because it is executed as a single instruction at the hardware level, making it extremely efficient. To recap, the bitwise AND operation compares each bit of two numbers. It returns 1 if both bits are 1 and 0 otherwise. We have seen how it's applied in checking even odd numbers, masking bits, and setting permissions. Now it's your turn. Here's a mini quiz to test your understanding. What is the result of 7 and 3? Try calculating it using the bitwise AND operation. If you are unsure, take a moment to walk through it before checking the solution.